This video is about derivatives for the functions depend on more than one variables. Let's start function depend on two variables. Z equal to fxy. So for the given point AB in the domain of this function, how do we find the derivatives for this function depend on two variables? Since f depends on x and y, so when you are taking derivative, you have to say respect to which variable. Okay, for example, we want to find fx ab. Okay. This means we want to take derivative for this function respect to x at the point a and b. This one has been defined as a limit h goes to 0 f a plus h b minus f a b over h. Okay. By the definition, you can see the y we treat as a constant is b there. So its x is changing from a plus h to a. Similarly, we can find fy ab. H go to 0. If this time we fix x at a, b is changing from b plus h to fix x at a, and b is to b, okay, over h. This is similar to the definition of the derivative for the function depending on one variable. Okay, now we call this derivative partial derivative because that's a derivative with respect to x. So we call this one as a partial f respect to x. We have another notation for that. So compare with this partial, the same thing, okay? Compare this notation with like dy dx. Okay. Partial means your function, once you see this, this means your f depends on more than one variable. Okay. Once you see d there, that means your function only depends on one variable. So the same thing, just give you the information about what kind of derivative you are taking. Is it partial or just a regular derivative? Okay, now as we know, for the function depend on single variable, f prime x, which also we use this notation dy dx, and this one give you, okay, y equal to fx give you a curve, and its derivative give you slope of tangent for that curve. Okay, how about what's the meaning for the partial derivative? Okay, now let's look at that. Okay, remember z equal to fxy. What's the graph of this? It's a surface. Okay, that's important. I always emphasize on that. Otherwise, the whole sentence doesn't make sense. Okay, think about here. Is AB, point AB in your domain on the xy plane. AB is a point on the xy plane. You can say z-axis is 0. Okay. What this means? This means, okay, here is a B, here is A. Okay. Now, if you let y equal to b, okay, what is y equal to b means? On the xy plane, y equal to b give you this line. But y equal to b, if you are talking about in the space x, y, z, in this space, they really give you what? They give you plane like this. Okay. So we got a surface, we got a plane. Okay. Intersection of those will give you what? A curve. Okay. So obviously partial f respect to x on AB would give you what? Give you slope of a tangent. This point to go up. Give you slope of tangent of that curve. Okay. Similarly, you can let x equal to a, which give you another plane. X equal to a give you another plane, which is parallel with YZ plane. So this plane go up, intersect your surface again. Intersect this surface, you will get another curve. Okay. Then partial f respect to y would give you the slope of tangent for this curve. That's what the partial derivative means. Knowing the geometric meaning for those two partial derivatives is always important. Otherwise, you find a number, you don't know what are they. Okay. Now, so by the definition, you can see to find the partial derivative, for example, find the partial derivative with respect to x, or write this way. They fix y, let x changing. Okay. And therefore they tell you how to find the derivative. Now, how about the function depend on more than two variables, say 3, x, y, and z. Okay. Similarly, you can take partial derivative with respect to x, partial w with respect to x, and wy and wz. Now, we give a definition for the partial derivative. And why we call it partial derivative? Because they only talk about derivative corresponding to one variable. Okay. And we also talk about what's the meaning of it, which give you slope of the tangent for some curve. Okay. For some special curve. That curve is intersection of the two surfaces. Now let's look at how do we find the partial derivative. Now let's look at the example. F x y z equal to e to the x y and ln z. Okay. So for this function, this function depends on three variables. Now, what do we want to do? We want to find partial f with respect to x, partial f with respect to y, or partial f with respect to z. Okay. So first of all, let's find the partial f with respect to x. This also means what? You want to take derivative with respect to x on f. What's your f? Your f there is e to the xy ln z. Okay. By the definition, when you take a partial derivative respect to x, you fix y and z. Therefore, what that means? That means you treat it as a constant. Okay. So you treat z as a constant, therefore ln z is a constant. Therefore, this is equal to you can put a constant out. You take a derivative on this one, okay, only. And since we are talking about a partial derivative with respect to x, that means you treat y as a constant. Therefore, they give you e to the xy, then you take a derivative. Use the chain rule, okay? You take a derivative again on xy. They give you ln z, then e to the xy, then you take derivative of this one, treat y as a constant, they give you y. Okay. So we find the partial f with respect to x. Similarly, we can find the partial derivative with respect to y. That means you want to take a derivative. That's another way to write partial derivative. Okay. You just replace this f by its definition. Again, no, sorry, this is y. Okay. This time we take a partial derivative with respect to y. Therefore, we treat xz as a constant. So ln z is a constant. Take that out. You take a partial derivative e to xy. Okay. Y again, sorry. ln z. So you take a derivative of that, use the chain rule, give you e to the xy. Then take a derivative of xy with respect to y, give you x. Finally, let's see what is the partial f with respect to z. This means you want to find the partial derivative with respect to z. What's your f? Your f here is e to the xy ln z. How do you find the partial derivative with respect to z for this function? Simple. You treat xy as a constant. So e to the xy is a constant. Put that constant out. Then find the partial derivative with respect to z on the ln z. Therefore, you got e to the xy, and take derivative on the ln z, give you 1 over z. Okay. Then we're done. Okay. So, to find the partial derivative for the function depending on more than one variable is very simple. You just need treat, if I want to take derivative with respect to x, I treat yz as a constant, just like you take derivative before. So as long as you know how to take a derivative for the single variable functions, then you can take a partial derivatives. Okay. So this tells you how do we find the partial derivative. So next sense is like, how about your function has been defined as an implicit function? For example, I have an equation like this. So ask yourself, what's the graph of that? You look at this the left hand side, you see x, y, z there. You say, hey, this is a function depending on 3 variables. But it's really not, because what? For given x and y, z cannot be anything. Okay. Z must be something, make this equation true. For example, if x equals 0, y equals 0, then your z must be 1. Okay. So this really tells you what? Z is a function of x and y. Okay. In fact, you can solve that. Z equal to -1 minus x minus y. Okay. In fact, we know that what? Graph of that is a surface. And what kind of surface is that? Really is a plane. Okay. Okay. For the function defined like this way, fx, y, z equal to 0. This is really just like implicit function. Okay. Think about that. You can solve the z, okay, equal to g sub x and y. Okay. So we call this kind of function implicit. This one, explicit, but they're the same thing, okay? Okay, if I give you the function as an implicit function, how do you find its derivative? Now let's look at the example. X squared plus y squared plus z squared plus 6xyz equal to 1. Okay. So what do we want to do? We want to find partial z respect to x and the partial z respect to y. Okay. Okay. Let me write it here again. Okay, x squared plus y squared plus z squared plus 6xyz equal to 1. So first of all, you have to know what kind function is this. This really is not a function depending on 3 variables. This is a function this is an implicit function in this form, okay? If you are able to solve the z, you can write it in this form. So even you see 3 variables x, y, z there, but x and y, they really play a different role as z play. So in your mind, you think about z is a function of x and y, okay? And x and y can be anything, but z cannot. Z has to depend on x and y. Okay, now how do we find the partial z respect to x? What we're going to do, we take a partial derivative respect to x on both sides of the equation. Okay, the left hand side and right hand side, they're both function of x and y, so we can take a derivative respect to x. But x and y, they are independent. Z depends on both x and y, okay? So we take a derivative of the first one, give you 2x. Remember, y there's no relation with x, so y is so you take a derivative, y is a constant, so the second one give you 0. Okay. The third one, okay, remember z is a function of x and y, so z depends on x. When you take a derivative, use the chain rule, give you 2z, then partial z respect to x. Okay, then plus, take a derivative of last term respect to x. Now look at this. You have x, y, z. X depends on x. Y is independent of x. Z depends on x. Therefore, use the product rule. Here you treat y as a constant. Z is not constant because z is a function of x and y. Okay. So use the product rule. Y is a constant, you can pull that out. So x times z, take derivative with respect to x, give you 1, times z, give you z. Then plus, fix x, take derivative of z, respect to x. What is that? We don't know that. That's what we're looking for. So just write that. Partial z respect to x. Okay, the right hand side is a constant. You take derivative, give you 0. Now, in this equation, partial z respect to x is our unknown. So put all those unknown terms together. We got the coefficient is 2z, then plus xy. That's the coefficient for partial z respect to x. Put the rest of the things which we know on the right hand side. So it's minus 2x minus yz, right? 1, 2, 3, 4 terms. Okay. So partial z respect to x give you minus 2x minus yz divided by 2z plus xy. Similarly, you can find the partial z respect to y. Okay, I think you probably have a problem at the beginning. Say y partial z squared respect to x give you 2z partial x. Remember, use chain rule. So now we want to change x and make z the same. So we do this. Partial z squared respect to x, you make it this way. Z squared. Then d that functions partial x. Okay, this is like a dy dx equal to dy dz dz dx. Okay, the first part now is z here, simply give you 2z and the partial z respect to x. Remember, dy dx equal to d dz dy then dz dx. Okay. Alright, so this example tells you if your function has been given as an implicit function, how do you find its derivative? Okay. So one more thing we need to learn here is a higher derivative. Let's use this example again. Say w equal to e to the xy, then ln z. Okay. Remember we find this is our f. Okay, this is our f. Remember we find fx equal to what? Ln z, right? Then times e to the xy, then times y. Okay, now similarly we have fy and fz. Okay, now we have for the function depend on 3 variables. We got 3 first derivative. Okay, so how many second derivative? For example, fxx. What that means? Remember, for given function fx is another function of xyz. So fx x is like this. You take a derivative respect to x on fx as a function itself. Okay. So what that means? That means also you can use this notation. This means you want to take a derivative respect to x on the result of the first derivative respect to x. So what is the partial f respect to x? Which is ln z e to the xy y. Okay, just take a derivative again. How do we take a partial derivative respect to x? You treat yz as a constant. It's simple. Okay. So ln z and y, they are constant. Put that out. Y ln z. What you really need to do, take the partial derivative with respect to x on this sense with x only. So they give you take a derivative with respect to x, give you e to the xy, then you take a derivative of xy respect to x, treat y as a constant, so they give you y. This is just like you take a derivative on 2x, you got a what? 2. Now instead of have 2 there, we have y there. Okay. Then we can find what? fyz. What that means? That's the second derivative. Okay. That means fy is partial derivative with respect to y, which is a function. Okay. Then you take derivative on z, on that function. Or you write this way. Partial z partial y. What that means? That means you want to take a derivative with respect to z on the result of partial f partial y. For this case, remember, partial f partial y, go back, is a function like ln z e to the x y x, right? Okay. Now, we want to take a partial derivative of this function respect to z. That means you treat x and y as a constant. So this part is a constant. So they give you x e to the xy. You just need to take a derivative of the first one, give you 1 over z. And so how many second derivative? We have what? fx, fxy, fyx, fyy, fxz, fyz, and so on and so forth. Okay. But I want you to know fxy equal to fyx, which means the one on the left hand side of this equation means you take a derivative with respect to y first, x second. The right hand side take derivative y first, x second. They're the same for the most of function you are dealing with.